Hi everybody, today we're going to be talking about dilations, and the first type of dilation we're discussing is enlargements. But first we're going to look at the entire definition of a dilation, and then we're going to focus in on enlargements. So a dilation is a transformation that reduces or enlarges a figure to create a similar figure. I want to underline this. Please underline this in your notes. We are not talking about congruent figures anymore. We are now talking about similar figures. And the reason why is because although we have the same shapes, we now will have different sizes when it comes to these figures. So in a dilation, the figure is enlarged or reduced to a fixed point called the center of dilation. I think you guys remember that when we did rotations, our center of our rotation was always the origin. Well, it's the same exact thing for a dilation. So right now I want you to put in parentheses origin, because in 8th grade, all we will be doing is doing center of dilations at the origin. So every single dilation will be centered about that point. Next thing we're going to discuss is the scale factor, and the scale factor of a dilation is the ratio, there we go, ratio of the side length of the image to the corresponding side length of the original figure. Now remember, a ratio is a comparison of two things, and we are going to be comparing side lengths of the original figure to the new figure or the image, and you're going to see that they should be growing or reducing at the same rate. And that's where this next blank comes into play. The corresponding sides are proportional. And all that fancy word means is that as one part of the shape gets bigger, the rest of the shape gets bigger at the same rate. Think about dilating your eye at the eye doctor. They don't just make one part of your pupil bigger. The entire pupil gets bigger at the same rate. So that's what that means, being proportional. All right, next page. This is our coordinate notation for a dilation. We always like to tell what happens to our x coordinate and our y coordinate. K is going to be the letter that represents the scale factor, and that says that right here. So go ahead and just circle this so we know that the letter K always represents the scale factor. So our coordinate notation for the x coordinate and the y coordinate will look like this: K times x and K times y. Because a figure is going to get a certain number of times bigger or smaller, we are going to be multiplying each the x and the y coordinate by our scale factor, which in this case is known as K. In a reduction, it's important to remember this. This is so important. Our scale factor is always between 0 and 1. So if something's getting smaller, that means we're going to be multiplying by numbers that are either fractions or decimals that are between 0 and 1. So that's really important to remember. An enlargement is going to be a scale factor, or multiplied, let's put that word in there, by a scale factor that is greater than 1. So that means something's going to get 2 times bigger, 3 times bigger, 100 times bigger. The scale factor will always be greater than 1 when the object is getting bigger. You might ask, what happens if the scale factor is actually 1? Well, if the scale factor is actually 1, and I substitute a 1 in for K up here in my coordinate notation, anything times 1 is itself, so the figure would just remain the same size. So we don't usually multiply by scale factors of 1 because that would just produce a congruent figure. And we're now looking at similar figures. Let's do our first example. Example 1 says draw a dilation of triangle ABC with vertices A, 1, 0, B, 3, 3, C, 3, 1 using a scale factor of 4. Well, since that scale factor is greater than 1, we know the object is getting bigger. The 4, let me go ahead and highlight that for you. The 4 tells us that it's going to be getting 4 times bigger than it started. So this is how you're going to go ahead and graph that new figure. You'll start by putting in the original coordinates. So we're going to write A, which is 1, 0, 0. And I'm going to go ahead and draw an arrow because I know that's going to become a new point after my dilation with a scale factor of 4. And that will become A prime. And now we need to figure out the coordinates. Remember, the scale factor of 4 is multiplied by each of the x and the y coordinates in the point that we're given. So if I look at the 1 and I multiply it by my scale factor of 4, my new point, 1 times 4, will be 4 for the x coordinate. If I look at my y coordinate of 0 and multiply that by 4, 0 times 4 is 0. So my new coordinate for A prime is going to be 4, 0. So down here, if you'd like to go ahead and draw that, I'm going to do that in a purple color so you can see it a little bit better. I'm going to go ahead and put A prime at 4, 1, 2, 3, 4, 4, 0. So this point right here is A prime. So go ahead and write that in on your graph as well. So we now know A prime. Now let's take a look at B. B is listed as 3, 3. So if we go ahead and apply the same rule to get to B prime, we are going to take both the x and the y coordinate and we're going to multiply them by 4. So 4 times 3 is 12 and 3 times 4 is 12 because both the x and the y are the value of 3. So my new point will be 12, 12. Now if you want to, this might make it a little bit easier for you to remember in the future, you might want to draw an arrow saying that this 3 is being multiplied by the scale factor of 4 to get to our new B prime coordinate of 12. And this 3 is also being multiplied by that same scale factor of 4 to get to that y coordinate. Now let's go ahead and graph 12, 12. Well, let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sorry, these aren't numbered, so we have to actually do it ourselves. That point is going to be B prime. So go ahead and label that. Now we only have one left. We have C. So let's go ahead and write the original coordinates of C, which is 3, 1. And once again, same exact rule. Same exact rule. We are going to multiply both the x and the y by our scale factor of 4. So C prime should become 3 times 4 is 12, comma, and 1 times 4 is 4. So remember, write this in if it's going to help you to remember. You are going to multiply the x coordinate by 4, our scale factor, and the y coordinate by 4, our scale factor. Then you're going to go ahead and graph that point. So now we have 12, 4, 1, 2, 3, 4. This point right here will now be C prime. Now you're going to have a ruler. I do not. So what I'd like you to do is just make sure that you are, I'm going to make this nice and thick for you guys to see. I just want to make sure that you guys know that when you are actually doing your graphing, you should be using a straight edge because you will see these lines much better than mine are going to be. There's A to B to C. So now if I look at triangle A prime, B prime, C prime, that triangle is 4 times greater than the original figure ABC. So we call this a dilation with a scale factor of 4 about the origin. That's how you would describe that. Okay, let's look at our next example. Example 2, and I went ahead and wrote some of the coordinates already. A is located at -1, 0. A prime is located at -3, 0. B is located at 1, -2. B prime is located at 3, -6. C is located at 1, -4, and C prime is located at -3, -12. Now these two figures were given to us, and it says find the scale factor of the dilation shown. So what we're going to do is we're going to look at what is happening between our coordinates from A to A prime, B to B prime, and C to C prime. You can go ahead and do D to D prime, but I'm hoping that by just showing you 3 that you get the picture and you can apply the same rule to D. If I go from -1 to -3, scale factor is always a multiplication. So -1 times what number gives me -3? Hopefully you're telling me it's 3. So -1 times 3, write this in, gives me -3. Let's check and see if it works with my y coordinate. Well, my y coordinate is 0. And if I take 0 and I multiply that by 3, I am getting my a prime y coordinate, which is 0 as well. Let's go ahead and see if that same scale factor of 3 will work for b. If I take my original x coordinate, multiply it by my scale factor of 3, I get 3, which is b prime. Perfect. If I take my y coordinate, multiply it by the scale factor of 3, -2 times 3 is -6. Hey, it's working for b. Let's try one more. -1 to a -3 for c to c prime. If I multiply by 3, guess what? It works. -1 times 3 is -3. Let's look at our y coordinate. -4 times 3 gives me -12, so that one works as well. So this is what you're going to do down here. You're going to write scale factor, and we can go ahead and abbreviate with SF, and that is equal to 3. And that matches because we said there are enlargements only when the scale factor is greater than 1. And in this situation, it's 3, and it got 3 times as big. Perfect. So hopefully you understand a little bit more about how to draw a dilation with an enlargement and how to figure out the scale factor. Now you're going to do some practice. So good luck. We'll see you soon.